Now we're starting section 5.2, which is going to focus on what will actually limit a population growth. Limiting factors to exponential growth are anything that will decrease a population. So we're going to call that a limiting factor. If you can remember back to chapter 3, we talked about limiting nutrients, where there wasn't a specific enough nutrient, and it was going to kind of wreak havoc on the ecological pyramid and that type of thing. Well, that's kind of a more specific term for something called limiting factors. So limiting factors is something that's going to decrease a population. So there's two different types. There's density-dependent factors and density-independent factors. Some of the density-dependent factors: competition, predation, parasitism, and disease. And some of the density-independent are drought, climate extremes, human disturbances, that type of thing. So the next couple of slides are going to go into more specifics on each of these. So density-dependent limiting factors. These factors only become limiting when the population density reaches a certain level. So that's why they're density dependent. So it has to reach that certain level of population before these become limiting factors. When a population is low, these factors are lessened. They don't play as big of a role. And again, that whole idea is looking at our exponential population growth. What is going to change that? What's going to affect that? And what may affect a logistical growth as well and cause some of those variations that we might see. So 3 different examples: competition, predation, and disease. Think about the first one, just for competition. The more species there are, the more competition between things, the higher the population. So let's take, for instance, maybe coyote. So if you have only one coyote in the area and all of a sudden the population reaches 5, and where one coyote didn't really have much competition for resources, 5 of them are now going to compete probably for similar resources. So that might limit the population. We can also look at predation. If there is the higher population, so when we think of the bunny rabbit, someone made the comment in class about, wait, if there's all these rabbits, what about a natural predator? Can we introduce a predator there? And that's what will happen. If there's an overabundance of a certain population, it's going to bring different or more predators in as well. But it has to get to that certain level. Again, we think about the carrying capacity for an ecosystem. And the other one is disease. Again, just as things become more prevalent, you're going to get diseases and whatnot that are going to become rampant and are going to have more of an effect when the population reaches a certain level. So we're going to go on and talk a little bit more specifically about predation. So predator-prey relationships. The regular of the population by means of predation is one of the most common mechanisms of population control. So in your book on page 126, there's a moose and wolf populations on Isle Royale, and notice the population trend. So if we look at this is very similar to what we saw in Oh Deer. So as the population of moose went up, we have the wolf population, and notice what kind of happens between them. As the wolf population is going down, what's happening to the moose population? And what happens to the moose population when, wolf population when the moose goes down. So we're seeing kind of some different intersections, that type of thing, that give us an idea of how are these two related, and is there a relation? So if we had to guess what the next 10 years would look like on this graph, what would you say? What would you think? What do we see going on right here that might give you an indication of what will happen in 10 years? So ending in around 1995. So think about it. So what did you think? If this was remembered our moose population, and this was our wolf population, where we were at in that 5 years was kind of this in this area. So our moose population was going down and our wolf population was going up. But notice what happened afterwards, right? In kind of this area right here, we noticed that the moose population dropped, and at that point the wolf population was going up, but then notice the wolf population ended up dropping as well. So there's kind of this combination here of how they are linked together. So if you put a predator's population is dependent on the prey, and as the prey population changes, so will the predator population, and vice versa. So what seems to trigger an increase in the link population if we look at this graph? Again, very similar to the graph that we just looked at. And again, just notice how these lines look. As one goes up, what happens to the other one? Are they completely in sync, or are there some different variations in that? And we'll take a further look in class about how could we explain some of these variations, that type of thing. What might be some of those causes? So we took a focus looking at density dependent. The final one we'll look at is the density independent limiting factors. So these are factors that are going to affect the population no matter how big or how small. And they'll affect all populations in similar ways. And again, we kind of talked about this in class, that that's not necessarily always true. They are going to affect all populations, but not necessarily in similar ways. It really depends on the population and what specific population we're looking at. So we talked about, think about detritivores or decomposers. If there's some natural disaster that all of a sudden we have this abundance of organic decaying material, these species are probably going to thrive, but most likely it was the other species, the consumers, higher level consumers, that are going to not do so well, so for population. So go ahead and cross out that similar ways and just focus on the idea that they're going to have some type of effect on the population. So examples, and you guys have already stated this in class, so it shouldn't be a big new idea. Unusual weather, natural disasters, different seasonal cycles, human activities, deforestation, damming rivers, anything that's basically going to have an impact on the specific ecosystem and the resources that are available in that ecosystem. So this ends section 5.2.